This video will go over the properties of parallelograms. This lesson will teach me to apply the properties of parallelograms. So I know you don't see this when you're looking at your particular lesson, but in the packet for the year 2017-2018 on page 10 you have several warm-ups. So I put these in the packet this particular time, and this was something that we would have done in class. So go to page, like I said, in 2017-2018 school year, go to page 10 of your packet, and it says lesson number 2 warm-up. Complete the 2-column proof. There's about 6 steps. And then I give you a couple of hints. I'm telling you on your paper that this symbol is the word parallelogram. And then the second hint said, what do you think you can assume to be true in a parallelogram? Well, the idea that because it's a parallelogram, its main property is that these sides are parallel. So if you think about doing a 2-column proof, what we're trying to prove is that the opposite sides are congruent, meaning that AB is congruent to CD, BC is congruent to AD. That might very well be something you know to be true about a parallelogram, but the idea here is you're proving it. So in the given statement, it says given that you have a parallelogram. So statement 1, parallelogram AD is given to me. So there's my reason. Because it's a parallelogram, what do you know to be true? I know that parallelogram has 2 pairs of opposite sides that are parallel. And how do I know that? Because I know what the definition of a parallelogram is. It's a figure with 2 pairs of parallel sides. And I'll get to that a little bit more. Again, this is something we would have discussed as a warm-up in class. The idea of parallel lines, you got to think back to alternate interior, corresponding, all of those things. So if you look here for a second, because we know that we have parallel lines, think about AC as being that transversal. What you're going to have then is you're going to have alternate interior angles here, congruent, and if you use these lines and that transversal, you have those pairs of angles congruent. So because we know we have a parallelogram, we know that the sides are parallel. We know that those angles are both going to be congruent, because if lines are parallel, alternate interior angles are congruent. And then think about kind of where we're going. I don't know, and again, this is something we talked through in class. I see 2 triangles. Yes, there's a parallelogram, but I see 2 triangles. So if you can prove that this triangle, let me get something to color with, that if you can prove that this triangle is congruent to this triangle, then we can prove all the pieces and parts are congruent. So recognizing that I'm trying to see 2 congruent triangles, and again, this is something we would talk through as a warm-up in class. This isn't something you'd have to make up on your own, but I do think there's a proof on your homework. I see that there's this line here that's reflexive, and that's going to be the next statement of my proof. It's going to say that AC is congruent to AC because of the reflexive property. So thinking about the different ways to prove triangles congruent, and again, the purpose of this is to kind of refresh all of those things in your brain. We've got parallel lines, congruent triangles, all of that. I see angle here. Oops, gotta get something to write with. I see an angle, a side, and then an angle, a side, and then an angle. So those 2 triangles are going to be congruent by angle, side, angle. And then if you remember the CPCTC that says corresponding parts of congruent triangles are congruent, simply means that because the 2 triangles are congruent, all other pieces and parts must also be congruent. So if you think about some of the things you know about parallelograms, those opposite sides are congruent. You know that to be true, that because you have a parallelogram, that this side is congruent to this side and this side is congruent to that side. Yes, that's true in a parallelogram, but it's true because of alternate interior angles, the reflexive property, because of congruent triangles, and because of CPCTC. So that would have been a warm-up that we would have walked through in class. Let me kind of get through these notes. Some definitions. Quadrilateral is a polygon with 4 sides, quad meaning 4. A parallelogram by definition, so this is the definition of parallelogram. It is that's a quadrilateral with both pairs of opposite sides parallel. So in that proof we just did, we have 1, 2 pairs of opposite sides parallel, and from that, as we draw diagonals through, you have alternate interior angles. A diagonal is a line inside of a shape that goes from vertex to vertex, but is not an edge. And I know it sounds silly to go through this, but every year I have students that just don't really seem to get that, which is fine. We'll work through it. But a diagonal goes from a vertex to another vertex and is not a side length. So from one vertex to the other vertex, it's on the inside, so it goes diagonally across that shape. Properties of parallelograms. You have in your notes, let me turn to my page, you have a shape off to the side just like I do. I'm going to add some markings and I'm also going to add some annotations under here. So there are several properties. The first one is two pairs of opposite sides are parallel, and this is actually from the definition of a parallelogram. Parallelogram. So let's mark it. We have those sides parallel, so that AD is parallel to BC and that AB is parallel to DC. So again, by definition of a parallelogram is two pairs of parallel sides. The rest of these are all theorems that can be proven, which is what we just did in that proof, which again would have been the warm-up, saying that AD, opposite sides, are congruent. We have two pairs, so that segment or side AD is congruent to BC, and that AB would then be congruent to DC. And again, that might be something that you've known before, but again, it comes back to the reasoning why these things are congruent, has to do with that idea of congruent triangles. Two pairs of opposite angles are congruent, so that means that opposite angles, meaning across from each other, are going to be congruent. So angle A is congruent to angle C, and angle D is congruent to angle B. And again, as we could work through that, I could prove any of these to you because these are actually all theorems. Consecutive angles are supplementary, and there's really no markings that you can make, but the word consecutive means angles that are right in a row. So for instance, angle A, the measure of angle A, when added to the measure of angle B, that's going to equal 180 degrees. That if I were to take the measure of angle A and add it to the measure of angle D, that's going to equal 180 degrees. So these angles that follow each other right in a row, A and D, A and B, we could say B and C are going to be 180. We can say angle D and angle C are 180. The idea of supplementary, and what this is coming from, is think about these parallel lines cutting through, and if you use this as the transversal, these angles would be same side interior angles, and we know that if the lines are parallel, then same side interior angles are supplementary. Kind of thinking that through, let's see if I can move that a little bit. If you were to use then these as your parallel lines, and this is your transversal, you'd have same side right here. You'd have same side right there as well. So all of those combinations would be same side interior angles, and same side interior angles are supplementary, but there are really no marks that you can add to that diagram. And then lastly, and this is the one I think is the most challenging to understand, it says that diagonals bisect each other. What that means is that they cut each other in half. So draw your diagonals. I have a diagonal from AC and a diagonal from BD. When it says they bisect each other, it does not mean that the diagonals are equal. Look at the length of these. AC is visually shorter than DB. So in order to mark it, I know that these two things are each being cut in half from meeting at that center, but it doesn't necessarily mean that they're the same length. And the other thing that I want to add is that these diagonals are not 90 degrees. These aren't perpendicular. Look at that angle. It's not a 90-degree angle. If it were a rectangle, maybe we could start playing around, or even a square, definitely a square, not in a rectangle. We could play around with the idea of those being 90 degrees. But if you look at that parallelogram, it's pushed over. So think about that motion when your car door doesn't close and you kind of like bump it with your hip. That's exactly what this parallelogram is. It's a rectangle which would have had congruent diagonals to reach that's now been bumped, and the whole thing kind of shifts. So this diagonal has to stretch, which is why they're not the same length, but what they do is cut each other in half. So if this one is 20, then we've got 10 and 10, and if this one is 10, then we've got 5 and 5. So cutting each other in half, something to write down might be that I don't know, I gotta call this something, AE would be congruent to EC, and DE would be congruent to B, something like that. So I know that got a little bit messy, but there's all your properties. So I better get going. I'm kind of running out of time here. In each parallelogram, find the specified measure. If you notice for this particular parallelogram, they're giving you side lengths. So you got to ask yourself, so what do I know about the sides of a parallelogram? Well, we know that the opposite sides here are congruent. So I know that 2x plus 4 is going to be equal to 10. So that's going to give me 6, so x equals 3. And again, it's because parallelogram has opposite sides that are congruent. It says find each angle. In a parallelogram, what do you know about the angles? You know that the opposite angles are congruent. You know that the consecutive angles, because of that idea of parallel lines, are supplementary. So if that's 103, that's got to be 77. So that one also has to be 77. And then this very last one, so my free program only gives me 4 minutes or 15 minutes. So I've only got 4 left, so I'm going to hustle. What are these things? From B to D, from A to C, these are diagonals. And we know that the diagonals of a parallelogram cut each other in half. So that means y equals x plus 1, and it cuts it in each other in half the other way. So that means 2x equals 3y minus 7. This is referred to as a system of equations. Because it's 2 equations with 2 variables, this is an Algebra 1 concept, you solve it by substitution. Because it says y equals and y equals, if you replace that y with its corresponding value, you end up with an equation that you can actually finish, because otherwise you would have had too many letters. So let's see, that's going to give me a negative 1x is equal to negative 4, so x equals 4. So that means if this is 4, that's a 5. That's going to be 10. Let's see, if x equals 4, then y must equal 5. So y is 5. Look at that. We know we're right because it split each other in half. If y is 5, 15 minus... Oops, I made a mistake. If x is 4, then that should be an 8, right? So that should also be an 8. Phew, glad I fixed that. So the idea here is that the diagonals aren't the same length. And again, if you think about that rectangle, a rectangle, they are the same, and we'll get to that later. But a parallelogram is a rectangle that's kind of been pushed over, and it's in pushing that over that one of those diagonals has to elongate. So again, here we just solve a system of equations. They're not all that complicated, but I did want to show you one. And again, that process is called substitution. So do the best you can. I believe your homework is out of the textbook. Please let me know if you have any questions.